Okay, quick video on how to solve problems like this. This is not something that came up explicitly in class or in the packet, although it did get mentioned in the book, and you have a problem like this on your quiz this week. So here we go. This is a partial fractions problem in which the denominator, here I factored it for you already, factors into a linear and the cube of a linear. Okay, so what should we sort of do now? Well, once again, in keeping with my explanations for all of these, let's do it sort of the first time, not the right way, or not the most efficient way at least. And by that I mean, let's just split it up into some number of x minus 1s and some number of, okay, I know how to do this in my head, so I just will. When you cube x minus 2 cubed, you get x cubed, let's see, now that I said that, better not mess it up, plus 12x squared, minus 12x squared, that's just like not even right, it's minus 6x squared, let me just focus for a second, yeah, plus 12x minus 8. I suppose I have that on my paper somewhere even. Yeah, I do. Okay, in other words, let's just not care for the moment that this is a perfect cube, and let's just treat it like a generic cubic. This is ultimately going to be not what we want to do, but okay, we do this. So, well, what then do we do next? Well, we have to say that because this is a quartic down here and a cubic up top, that the degree of the numerator here is less than the degree of the denominator, and so must each of the pieces that we split it up into have that same property, that the degree of the numerator is less than the degree of the denominator. So I can say that this is going to be a number, and I can say that this is going to be some kind of quadratic, bx squared plus cx plus d. Okay, and now what? Well, now we just do it. So if we multiply it through by these two denominators, we get 5x cubed minus 28x squared plus 55x minus 34 equals, this will be a times x minus 2 cubed plus this whole thing, bx squared plus cx plus d times x minus 1. Hopefully this isn't too hard to actually solve. Let's do it now. What are some things I can do? Well, I can plug in x equals 2, say. Certainly I can do that. What happens then? It's not as helpful as you might think. Let's plug in x equals 1 first, because I might like that. If I plug in 1, the nice thing about that is that all of this disappears. And so I think I get negative a on the right. And on the left I get whatever I get when I plug in 1 here. Let's see, 60, negative 2 it seems. Yeah, negative 2. Okay, so a is 2. Alright, that's sort of 1 down, 3 to go. Is there anything else I can get sort of easily? Yeah, I think that the x cubed term is something you can just look at and see right away. That if you were to expand this x minus 2 cubed, you'd get a leading coefficient a. And here, the only cubic term you're going to get is when you multiply bx squared by x. So sort of fake multiplying out in my head tells me that the cubic term is going to be a plus b. And since on the left the cubic term is 5, that tells me that b has to be 3. Okay, so that's kind of nice. Anything else I can get kind of for free? I think if I plug in x equals 0, that's going to be a good thing to do. So let's do that. Why is that so good? Well, I'm going to get certainly negative 34 on the left. I'm going to attempt to squeeze this in. But on the right, when I plug in x equals 0, let's see, that will give me 8a. Maybe I won't be able to fit it. 8a, negative 8a. Because when x is 0, yeah, negative 8a. And when x is 0 here, I get d times negative 1, so minus d. Okay, so let's see. So 34 is 8a minus d. But also, a is 2. So that's 16. So I think D is 18. Is that right? Yeah. All right, and now just one more left to go. Screams from downstairs. Maybe now I'll plug in 2. So if I plug in 2, that should do it. Although I'm not so excited to plug in 2 over here. I think I'll even just do some synthetic substitution, since that's the easiest way. So that's 5, 10, negative 18, negative 36. Whatever that is, 19, I guess. 38 and 4. So I hope that's true, that when I plug in 2 on the left, I get 4. When I plug in 2 on the right, well, that does, and that becomes a 1. So yeah, I guess I get 4b plus 2c plus d. 4b plus 2c plus d. Not sure if this was the most efficient way to do this, but anyway, b is 3, so that's 12 plus 2c plus d is 18 equals 4. So that's 30, so I guess I get that 2c is negative 26, c is negative 13. Yeah, all right. So that's kind of good. All right, took a long time, but I won. And here is what I found. What I found is that this is, let's see, well, so maybe I'll just go right here, right? So the answer is 2 over x minus 1 plus 3x squared, and here I picked very nice numbers, minus 13x plus 18 over x minus 2 cubed. Okay, and here, in keeping with the way we've been doing this, I'll say that this is correct. So it is not wrong. However, though it's not wrong, it's also not the simplest, most broken down possible form of this rational expression. And that's because I may do this thing, which is kind of a sort of a harder version of what we did already, which is to think of this quadratic divided by this x minus 2 cubed, to think of it as 3x squared minus 13x plus 18, kind of like divided by x minus 2, but then the whole thing divided by x minus 2 squared. In other words, let's divide, I think that's what I want to do. No, other way around. First, divided by x minus 2 squared. Yeah, that's what we want to do. So let's kind of see sort of what's really going on up there. In other words, just kind of, instead of dividing by x minus 2 sort of 3 times, let me first divide by it twice. And I guess I'll squeeze my kind of scratch work over here. So what is 3x squared minus 13x plus 18 divided by x minus 2 squared? Well, that would be x squared minus 4x plus 4. And okay, we just do this, right? We get a 3, so it's 3x squared minus 12x plus 12. And so that becomes negative x plus 6. Okay, so what have I just learned? I've just learned that this is really 2 over x minus 1 plus, well, that whole numerator can now be written as 3 plus, and now the remainder is negative x plus 6 over x minus 2. And yet that whole thing is still being divided by x minus 2. Wait, hold on. That doesn't make any sense, what I just said. This should be x minus 2 squared, I guess. Maybe I did want to divide just one time first. No. This is good. This is good. Okay. Good. So now that I have done this is all totally right, because I did my polynomial long division over here, and so here now the sort of the red, the 2 red pieces are equal. But now I want to sort of further decompose, if possible. Well, I'll do sort of two things now. I'll write this as 2 over x minus 1 plus, I'm going to split up this fraction right here on this plus and write it as 3 over x minus 2. But also, at the same time, let me rewrite negative x plus 6 over x minus 2 squared as negative x plus 6 over x minus 2, and then over x minus 2 cubed. Okay, this is potentially a little bit confusing, but if you sort of follow what was happening here, well, we had negative x plus 6 over x minus 2 squared, but then divided by another x minus 2. So as soon as I sort of split this fraction up, I get 3 over x minus 2, and now it's just this that's kind of left, right? And so what is all of this? Well, let's once again go over here and do it. I think I'm doing this the intelligent way. So what is negative x plus 6? Negative x plus 6 divided by x minus 2. It's going to go negative 1 times, and that's going to give me negative x plus 2, and then has remainder 4. So, I have to squeeze 2 more lines in here. That's going to be 2 over x minus 1 plus 3 over x minus 2 plus, and now that green numerator, well, what is it? It is actually negative 1 plus 4 over x minus 2. But that whole thing was over x minus 2 cubed. And so, I will now, let's see, I'm just going to kind of try to salvage some board management here. Chop. Okay, so maybe I'll just kind of go over now for my final line. My final line is that this is 2 over x minus 1 plus 3 over x minus 2 minus 4. Sorry, that should be squared, of course. And that is squared down there as well. Yeah. Minus 1 over x minus 2 squared plus 4 over x minus 2 cubed. Okay, that explanation was a little bit sort of not perfect, but if you follow the algebra, I think it makes total sense, right? We got this answer that we were sort of happy with but not really content with. We decided to figure out sort of how many x minus 2 squareds were hiding in this quadratic. So we did that kind of polynomial long division, and the answer was that there were 3, plus some remainder. How much remainder? Negative x plus 6 was the remainder after dividing by x minus 2 squared. Then we chose to investigate that further by dividing negative x plus 6 divided by x minus 2. So we, by just one of them. So now we divide negative x plus 6 divided by x minus 2 with x minus 2 squared remainder, and then we get negative 1, and then with 4 remainder. So, okay, the point is that this exact thing is always going to happen. That our answer turns out like this. And we just like this better because it's simpler and broken up into more small little pieces. So the moral of this entire story is that in the future, when presented with this problem, we don't do that. Instead, we say, because we know that this is going to happen, we say that this is going to be some number of x minus 2's, some number of x minus 2 squareds, and some number of x minus 2 cubes. And that this will be, for all the reasons that we just saw here, numbers. And so the fastest, most efficient way to do this problem, if this was the goal all along, and it was, would be to set it up like this. Okay, great. Goodbye.